Hello everyone and welcome back to another episode. I know it's long due and there has been a long time when I've not posted a new video. Um, but I'll try to be more regular from now on. We'll continue on the series that we were building on how to actually start or learn threat hunting. And we covered a lot of theory and some amount of we put our first leg into understanding how to practically execute or realize the theory that we were learning. Today will be a second step, right? So we'll try to do a uh, bit more of technical hands-on and try to understand how we can better leverage the detection labs that we have created in the another series that we did. Right, we did a threat detection lab series, so you must have already got a lab if you would have followed that series. If not, go ahead and follow that series and get your lab up and running. In the last video we also discussed what all do you actually need to start hunting. Today we'll just reiterate and build on top of it, and we'll also see how to start actually hunting. Right, so we'll quickly jump in. So as we realized, we need a data set and we need a tool to actually give us some amount of querying ability. It could be a sim, it could be a data lake. Generally in my detection lab, if you would have seen, we generally have this covered via Elasticsearch, or we have it covered via Splunk, or we could have it covered via, or you could use anything of your choice, whatever you have. You could use Wazoo, you could use what else, you could use Greylog, right? um, and if you're very hardcore database enthusiast, go ahead, use ClickHouse or something, right? Use the database to stream your data into it. You would require some amount of engineering efforts here. Others are pretty straightforward, right? You in Elastic, you pretty much get ES plus Kibana plus Fleet plus agents, right? So it's a complete stack. In Splunk, sorry, you would have to do with a Splunk single instance deployment. You could do more complex, but I think this is what it is available for free. But there's a limitation of 500 MB of data ingestion per day. And plus you will have to do again some amount of universal forwarder plus your collection sorry your collector and log generator, right? The log generator here, obvious choices is one. You don't get elastic defend kind of a package that you get in elastic or EDR kind of a package. So you'd probably do sysmon plus velociraptor or plus osprey, right? Possible choices. Again, similarly, Wazoo, Greylog, ClickHouse, right? Some amount of engineering goes. So a general structure, if I had to establish, is you have a log engine and basically the data store, right? And then you have some amount of uh, uh, parser, collector, normalization engine baked into it. You have searching capabilities baked into it, and then all of the bells and whistles. There could be MITRE mapping, could be advanced querying, it could be AIML, it could be etc, whatever it is, right? But to reach your data here, you need some kind of a log shipper, right? So you do a log shipper. The log shipper that can directly pump data into your data store or log engine, or data lake, whatever it is, or what you also need is a collector, right? It could be a collector, it could be an agent, it could be a, and now this simple pipeline could be as complex as you add forwarders, right? You could add secondary storage, you could add data replicators, whatever you want, right? As complex as you want. This is a complete engineering feat you build on top of it, right? So similarly, that is how you get your SIM and data lake capabilities. To be fairly honest, if you're on the threat research side, keep it as simple as possible so that you focus more on security and less on keeping these tools up and these components up and running and debugging them. If you're on the engineering side, feel free to make it more as complex as possible to see how much learning that you could do or reap out of each of these deployments and stacks and different modes of deployment, right? So feel free to choose your flavor or choose your poison. But another thing that you will need to realize is you need a data set, right? Now this is where it is interesting. Most of the data set that is available in public are either outdated, or they are already researched, right? They are not ideal for practicing more, right? Or doing more of hunting, right? To be fairly honest, most of them don't even provide data set. What you would possibly get is samples of malware, right? That is also a bit tricky to get your hands on if it's a novel sample, but you generally are able to get a sample, and then you need to do whatever you want to do with that, right? So we'll set up something else today. We'll try to see if we can set up a pipeline of things where we have a mechanism to simulate data, simulate an attack. We'll do real-time data capturing and streaming to let's keep it simple, right? We'll do real-time log collection. We'll push all of this data into our SIM data lake, and on top of it we'll do the hunt, right? So this is the architecture that we'll build on from this video. We'll try to simulate. In certain cases there would be detonation, right, instead of simulation, but the other steps would remain same, right? If the other steps are still same, you do detonation, you do simulation, you do detonation, you do real-time log collection, you do SIM data lake and hunt, right? These are the two flavors. We'll try to also build into more advanced things. We'll do again, this would remain same, but we'll try to do more of adversary simulation at one stage, so that we have as near possible a data set that is as near to a real attack that could be leveraged to do other stuff, right? So these are the three things that we could do. We'll start by building here. It's easier here. There are a lot of simulators tools available. Then we'll move on to detonation of real samples, right? This would be more atomic in nature, or you can think of micro emulations, but these are real samples. And then there is adversary simulation or emulation, depending on what kind of lab setup or plan we are able to develop basis available threat intelligence, right? So more on this later. We'll start here. So how do we actually go about doing this is, we'll move this to at the bottom so that we have more space, right? So how we'll go about doing this is, once you have, for this stack, you need a simulation tool, right? For today's video, we'll use something called a PT simulator, very famous tool, very popular tool, a lot of uh, good good tests built into it. uh, there are more in future, right? That we will test. We can do atomic tests, atomic team by I think it's atomic red by red canary, right? We can start building on caldera. We can uh, do a lot more, right? So a lot of different tools are available. We'll start with the easiest one for today, that is APT simulator, and then we have our elastic agents that will be collecting logs from the host, right? So this APT simulator will be executed on Windows hosts, right? So elastic agent will collect two types of data, right? On a sysmon, we have already got sysmon up and running on this Windows host, and then we also have uh, elastic defend, right, running on this host. So we have sysmon and defend, right? So EDR and sysmon both running. That is what elastic agent will be collecting. It will all be pushed down to um, so I have a tricky setup. It is all pushed down to logstash first, on logstash plus fleet server. Basically logstash plus, think of it like logstash and Kibana. uh, let me try to make it more simple. It's all pushed down to Elasticsearch first, and then from Elasticsearch it actually flows to a logstash, and then logstash to Splunk, right? So I have data available at two touch points, basically two interfaces. One is my Kibana, and another one is Splunk, right? So once we have data, it's simple. We'll start hunting, right? Okay, simple. What we'll do is we'll just go and see the setup that I have. Let me just show you the Windows VM, right? And this is Splunk, by the way. Let me log in quickly and show you if I have data incoming. And then I also have my Elastic up and running. So if you can see, there is a fleet server and a Windows EDR policy running on a desktop VM. If I go to the policy, it has OS query, Elastic defend, and Windows integration, which is sysmon, right? All three working. So if I go to discover and Elastic defend logs, I have real-time data coming in, right? Event dataset, category, action, right? All of that is coming. I think Splunk is still a bit slow. I have not logged into Splunk for a long time. Also, it's running on very limited resources. But I do have developer license on it, so I should be fine on ingesting a lot of data. This is how my health of the cluster looks like, but let me go back to the search app. Okay, and let me do index source. source equal to star, and let's do index is equal to star, and fire up a search. Meanwhile it is running. Let us go back to the Elastic, right? Just put it here. Right, so okay, so possibly we'll use Elastic as central console for hunting. Splunk is a bit slow. I'll optimize possibly on the agent, on the resources that the container and VM is consuming. I have now taken a liking towards putting more things on the AI agent to do most of the searching and stuff. So I think I'll just possibly do that, or I can demo that in the next video, how you can use AI to orchestrate or build a detection lab, right? So quickly coming back, what we'll do is, let me also show you the Windows VM that I am running, right? This is the Windows machine. I'm also looking at a different screen. Yeah, this is the Windows VM that I have, right? I have got RDP onto it, so remote desktop is serving me well here. Let me see if I have okay, what we'll do is we'll do tweak a setting. This is important, right? So if you go to fleet agents, okay, this is painful. Agent policies, Windows EDR, right? There's a defend policy, right? So we'll just go to Elastic defend policy. We'll scroll down. We'll say enable to register Elastic as official antivirus for us. This will also disable Windows Defender, right? Which is a painful process, right? Defender is integrated in so many ways. Let us simplify this. We'll just say enabled. So now Windows Defender will get disabled. This will get enabled as the AV. And on the top, we have disabled malware protections, right? So we'll just enable malware protection. We'll put it into detect mode, right? So things get detected, or let us keep this disabled. Nothing gets detected, right? We only have raw telemetry. EDR is AVs are disabled, right? And that is the ideal situation for hunting. We don't want any detections to be triggering. We don't want any files to be quarantining. We don't want anything of that sorts to happen, right? We'll just say save integration, save and deploy changes. right? So if I go back to my fleet, agents, logs, um, okay, we don't have the latest entries. I think that the changes are being applied. We'll just close that. Okay, we will come back. We'll see this. We'll go to security settings. It says yes, status enable will open Elastic Security for information. That means Defender is overridden now by Elastic Security. Perfect. So no more hassle of registry issues, disabling Windows Defender via group policies and all of that, right? Simple. Perfect. So we now have everything up and running. Logs being streamed. All we need to do is execute MITRE simulator here. So we'll just go to the browser here. There are more automated ways to do this, but let's go with a very basic way of downloading and executing the binary here, right? So we'll just say stop. So we'll start setting up the simulation tool, which is APT simulator here. I'll just increase the size of this window so that it's visible. Right. Hope it is visible now. So what we'll do is we'll follow plain old simple method. We'll just go to Google, Google search, and then we'll do APT simulator, Nextron systems, and you see here APT simulator version 094. If you will stress on the repo and have a keen eye, you will realize a repo is a bit old, right? It's 7 years, 8 years old thing. It's a pretty old repository. So most of the tests or the cases that it will execute would be older, right? Would not be novel techniques or um, a different or a unique test as per today's threat landscape, right? Most of them would be a known technique or a known behavior. So it would be easier for most of the EDRs to detect it and catch it, and it should be easier for most of the EDRs and to catch it, given it's so old. But that also means that the techniques are fantastically documented everywhere around the internet, so it eases you to have that not it eases you to have a flat line learning curve instead of having a very steep learning curve, because you have a lot of supporting materials, right? So you are well rounded in the community, and support is readily available in forms of blogs, videos, and everything, right? So we'll just try to execute this one. Correct. Now we have the file. We will start executing. So we'll just extract first. There's a password. Let me try the Okay, incorrect. Let us go back to the tool and see where could be the password, right? Um, oh, it says password apt. Let us try this. If this works. apt. It worked. So please the password. Okay, Defender says threats found. Right, let us go back and validate if our policy is still overriding the Defender. It says enabled, so it should be. Okay, somehow so we'll just do extract all again and see this time threats are not detected because Defender is turned off. Skip these files. I think went well. We have APT simulator up here, and what we'll do now is I'll just increase the size a bit more. Right, and let me also change the resolution for easy viewing. Okay, can't change it from a remote session. Makes sense. Okay, we'll come back. I'll change the view to large icons. Or large icons, yeah. So we have the APT simulator here. What we'll do is we'll run this. I'll run it as an admin. Once you do that, it gives you a disclaimer. You want to proceed? Yes. Okay, now it has a list. It gives you a list basically. Let me see if I can increase the font size a bit more here. Okay, looks like this is also not working. So let me check if it is visible enough on the screen. Hope this is better. Yeah. So yeah. It gives you few options, right? 1 to 9 are all the MITRE tactics. Earlier there were 9 tactics on the MITRE matrix, so all 9 are documented. And then there are some optional tests which are addendum, right? Cobalt strike beacon simulation, uh, AV exclusions in registry settings. Uh, I don't know what settings does. Let's do settings. Okay, activate a random sleep interval between the test cases. Set the maximum second to wait between test cases. Interesting. Okay. So for staggered log generation, we could do that. But I'll exit to the main menu for now. You can run all of these tests by running 0 or select a few. For our use case, what we'll do is we'll try to pick some interesting ones. Let's pick um, persistence, of course. Let's pick defense evasion. Let's pick command and control, and we'll see how that goes. So we'll say 8 for persistence, right? Okay, it exited after executing persistence techniques, right? We'll also go and re-execute it, and this time we would say let's do defense evasion, right? So we'll do 4. Okay, download and install this feature. I'll skip for that. uh, and then I would also execute the command and control as we discussed, right? So we'll do command and control techniques. Okay, it ran and exited. So we ran 3 sets of MITRE techniques uh, or tactics execution. What we'll do now is we'll go and check and hunt for this, right? So we'll quickly log in into our Elasticstack. Got my Elastic up and running here, so I'll just log in. Okay, so I am getting logged in. Let us just into discover. And we'll go to Elastic defend logs. And I will change this to last 90 days. Okay, I think I have all the logs, 87,395 logs, so that's a huge data set. Let us start hunting by realizing the hypotheses, right? That is how we discussed during learning the theory, right? You need to have a base hypothesis. And then you need to also have a sub hypothesis or a testable hypothesis, which could be a subportion or the derivative of base hypothesis, which would be, let's call it the main hypothesis or the technical hypothesis, right? So the base hypothesis that we currently have is attackers are abusing our infrastructure and leveraging persistence mechanisms offered by our vendors to Windows environment. Attackers are abusing our infrastructure and leveraging persistent mechanisms to persist and cause disruption. Right? This could be your base hypothesis. This could be um, you as a new threat hunter understanding that persistence is an important tactic and let's hunt for it. This could be a popular threat intelligence, so it could derive from anywhere. Or say your manager asked, right? Or your hunt threat hunting team lead asked, let's hunt for persistence in our environment, right? And this is how you ended up creating this base hypothesis. Now the technical hypothesis is interesting. Now this is where you actually define what is possible. What we currently know is that we have to test persistence. We don't know anything apart from it, right? So if I just start digging into data, there are two routes I could take, right? I could take an unstructured approach, right? And then there would be structured approach. Now an unstructured approach would not make sense here. Why? Because the base hypothesis itself is structured, right? So there's some amount of knowledge you already have. Discoursing from here would mean chasing millions of rabbit holes without understanding what you are hunting, right? It's when you don't have a vision or when you don't have a target, you should do a unstructured answer. Not valid, right? Not valid in this scenario. Let us take a structured approach, right? Why? Now there should be a why question attached to this as well, right? Because we have some amount of variables defined, right? We know the tactic, persistence, right? We also know the environment, Windows, right? So we have at least these two pieces of information, right? Yeah, that is all that you can gather from this hypothesis. So once you have these two, it's easy to build on top of this, right? Like we'll go to our holy grail, we'll go to MITRE and start digging in. So just go to MITRE. Let us say Windows persistence, right? Now there are hundreds of techniques here, right? This is unpopular, right? Pick, start picking from the lowest hanging fruit, right? Pick whatever seems easiest to test and you have knowledge on, and start from there. Build more advanced knowledge while researching on the techniques that you don't know about, right? So we'll start with scheduler. We'll start with schedule tasks. This should be easy. If you click on this, it should say what to detect, right? If you say detection strategy, schtasks.exe, at.exe, cron etc is not valid for Windows, right? Launch agent non is not valid for Windows, it is for Mac. Cron sleep again not valid, esxi not valid. So the only thing valid is SCH tasks or at.exe. Let us do that. Let us move into ESQL mode. Should be good. Where process dot name equal to let's say name in at.exe or schtasks.exe, right? This is what it is. We'll go okay, I think we have an extra pipe here, right? This should work. We have 10 results because we have limited 10. Let's remove limit and then run. We still have 10 results. Okay, this is interesting. Let's do keep process dot name, process dot command line, process dot to parent process name, right? It should be process dot parent dot name, right? Process dot parent dot command line, right? Let us also take the host name, host IP, and this should be good enough. Unknown column process dot name SSMC, right? So we'll just run this and we should have a tabular view of all of these fields. That makes sense. We have SCH task, we have parent process, right? CMD, 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 CMD. And then we have SCH task execution where there is no details. Right, so we'll skip the ones that doesn't have any details. These are simple executions, right? Let us also pull in timestamps. It would be easier for us to correlate. The blank execution ones are also during the same time span, but I think they don't have anything attached. So we'll just say where process dot command line is not null, right? Because we don't want null values, we can't investigate, we can't trace them, right? So we'll just remove them from the results, and this is what it is. If I just put comma star, it will pull all the other fields as well, right? So somehow we were not getting the host name and other IP fields. So we'll do star, we'll check which field is actually giving that and put that value, right? It should be easier. Host dot name, and then we have There's a lot of interesting information. This should be good. Right. So now what we have is basically SCH tasks execution, creating ctmp.mim.exe, sec urlsa, logon passwords, outputting data to o.tmp, right? This is the pattern. And then you have the time period at which it is to be running, the name of the task, right? If you see this here, this is also suspicious, right? It creates a wscript.xml with task name as flash update 22, where flash is mispronounced, right? So it seems like this is typo squatted, so should be a suspicious event to investigate, right? You also have AT execution, right? Let us also put event.outcome as value. Okay, it says unknown. Ideally it should have said us what if it was successful or not, but you see first AT was tried on 4719, and then since AT is deprecated as far as I know in Windows environment, right? AT.exe. Yeah, it was replaced by SCH tasks. So most of the time AT commands would fail on a machine, and that is why I believe the attacker actually tried, or our simulation actually tried SCH tasks.exe, right? So this is how you basically went ahead to detect one of the threats. Now say we want to do more, right? So let us go back to persistence. Valid accounts is another common one. Let us see if there was an attempt to create a valid account, right? So we'll try to detect net. Another interesting thing that we should check is basically another interesting thing that we should basically search is via um, run key changes, so registry changes for run keys that would allow attacker to run their um, run their configured job, right, and persist in their environment. So what we'll do is we'll just change this process name. Now we will look for registry events, right? So our we don't know what registry change is, right? So what we are actually looking for is, let me just see if I can comment it here and say where process command line like run and also put up where event dot data set. Okay, let us forget this. Not getting enough hints. Let us see if we can find the name of the registry event. So another thing we'll check is persistence via registry keys. So let's go and search for run keys, right? So what we'll do is we'll say that where event dot dataset is equal to endpoint dot events dot registry. And I don't know the structure of the log for this, right? So possibly we'll just do limit 1 and get the first log, identify fields of interest, right? um, and we can search here. What we need to find is search for the registry key path value. So we'll just say where keep registry dot key registry dot path registry dot value host dot host name host dot host. I believe it was host dot host name. Yeah, so I'm getting some values and data. Do we also have process start name? To identify which process actually made the change, right? We do have that. So we can include a condition where event registry dot key like star run star. So another thing we'll check for run keys. So persistence via run keys is another popular technique and usually used by attackers in Windows environment. So we'll just put a filter that says we are looking for event.dataset equal to, we are looking for endpoint dot, I think this is we'll just put a filter where it says where we don't need process name now. We are filtering basis on our target registry modification. So where registry dot path, let us brute force this, right? Registry dot path like star run registry dot path like star. Since this is not a production grade detection or any detection, it's okay since we're querying the data, right? From a performance point of view, ideally this is not, there shouldn't be the query that you should be running. You should put more filters to narrow down the search criteria. But since this is a hunt and not a detection, and this is not a production environment, I can possibly go and brute force it and tune this query later, right? So run let's say run, right? Run once will also be getting detected, right? So we'll just say run. We'll say we still need host dot name. We need process dot name for process that modified the registry. We need registry dot path. What is this path? Registry dot value, key, right, and registry dot value. Right, let us search this. Yeah, like is case sensitive. Let's do R like and check if still getting. Okay, I think this is still case sensitive. Okay, like is case sensitive, so so now we have some data. Will be so another technique that you should apply while doing hunt is process of elimination. Eliminate values from your queries that are generating known behaviors, right, and known benign behaviors, right? For example, I understand that OneDrive will be modifying the registry because it will be running its operations, right? So what we'll do is also validate this, right? If you have this in production, check if the OneDrive setup.exe is having a valid hash and is a valid process, right? In this environment, I already know this, so what I'll do is I'll also put say a query filter that says removing benign processes, right? And we'll just say where process dot name not in OneDrive setup.exe. Similarly, there would be msh.exe, right? What else? Okay, I think these two are known here, so we'll just run them. We have now interestingly ctfmon application restart #1 #0. These are interesting. I would go back and check. Res.exe, what is the parent of this? Process dot parent dot name. It is empty. Okay, no problem. This looks suspicious, and like if I had to correlate back using time, the time actually matches when we ran the simulation. But if you see, but if you even if you disregard that this was a simulation, update svc seems a bit suspicious, right? Run key getting updated for update csv. I would definitely go back and investigate this, right? So this is another way how you can hunt. Now, what did we actually employ? If I had to go back and say what was our learning while doing this, structured approach while persistence, we employed two techniques, right? Techniques employed tested against um, One was scheduled tasks, another one was persistence via run keys, right? What was our learning, right? Our learning here was when you're hunting, you need to have intelligence context. Intelligence context. It could be blog, report, MITRE ATT&CK, etc. Wherever it is, right? You should have supporting information and detail that you'll be using to hunt, right? I think just move just up, right? So this is what you should have. That is one. Another learning that we had is a hunting technique, right? The hunting technique that we really saw is process of elimination. This is a very common technique applied everywhere, but we do apply while writing querying is remove all benign known behaviors, right? How do we do that? We filter via filtering. What is the fundamental why are we doing this? The fundamental principle is the smaller the data set, the easier it is to find the outlier, right? Or bad behavior, right? So ideally what we are also doing is we are solving needle in a haystack problem, right? So this was one good understanding if we are trying to do the base hunt in if you're trying to practice a hunt, is you get to learn how you actually pivoted and reached a point and devise back all the learnings and retry them when you're doing your next hunt, right? Okay, this was just one. We'll just see one more, and I'll put this data set in the in my Git repo so that you can go back and download this data set and start hunting. So you don't even have to simulate all of this. Just get the data set, ingest it into Elastic or whatever sim that you're using, and start hunting. For the third one that we executed, right, we did three: persistence, I believe privilege escalation, and command and control, if I'm not wrong, right? But we did three, and we'll do two of them in the video. One will be for you to practice and comment back the query or the hunt that actually worked for you in the YouTube video. If you have questions, also do put them. I'll try to help them and give you the answers, right? I'll DM you the answer. If you want to reach out to me, you can reach out to me over LinkedIn as well. Cool. We'll go to the second technical hypothesis. Our base hypothesis would be, right, base hypothesis would be again similar. Let us just say that using and leveraging. So another thing we'll check for the run keys. So persistence via run keys is another popular technique and usually used by attackers in Windows environment. So we'll just put a filter that says we are looking for event.dataset equal to, we are looking for endpoint dot, I think this is we'll just put a filter where it says where we don't need process name now. we are filtering basis on our target registry modification. So where registry dot path, let us brute force this, right? Registry dot path like star run registry dot path like star. Since this is not a production grade detection or any detection, it's okay since we're querying the data, right? From a performance point of view, ideally this is not, there shouldn't be the query that you should be running. You should put more filters to narrow down the search criteria. But since this is a hunt and not a detection, and this is not a production environment, I can possibly go and brute force it and tune this query later, right? So run, let's say run, right? Run once will also be getting detected, right? So we'll just say run. We'll say we still need host dot name. We need process dot name for process that modified the registry. We need registry dot path. What is this path? Registry dot value, key, right, and registry dot value, right? Let us search this. Yeah, like is case sensitive. Let's do R like and check if still getting. Okay, I think this is still case sensitive. Okay, like is case sensitive, so so now we have some data. Will be, so another technique that you should apply while doing hunt is process of elimination. Eliminate values from your queries that are generating known behaviors, right? And known benign behaviors, right? For example, I understand that OneDrive will be modifying the registry because it will be running its operations, right? So what we'll do is also validate this, right? If you have this in production, check if the OneDrive setup.exe is having a valid hash and it's a valid process, right? In this environment, I already know this, so what I'll do is I'll also put say a query filter that says removing benign processes, right? And we'll just say where process dot name not in OneDrive setup.exe. Similarly, there would be msh.exe, right? What else? Okay, I think these two are known here, so we'll just run them. We have now interestingly ctfmon application restart #1 #0. These are interesting. I would go back and check. Reg.exe, what is the parent of this? Process dot parent dot name. It is empty. Okay, no problem. This looks suspicious, and like if I had to correlate back using time, the time actually matches when we ran the simulation. But if you see, but if you even if you disregard that this was a simulation, um, update SVC seems a bit suspicious, right? Run key getting updated for update CSV. I would definitely go back and investigate this, right? So this is another way how you can hunt. Now, what did we actually employ? If I had to go back and say what was our learning while doing this, structured approach while persistence, we employed two techniques, right? Techniques employed, tested against, tested against. Um, one was scheduled tasks, another one was persistence via run keys, right? What was our learning, right? Our learning here was when you're hunting, you need to have intelligence context. Intelligence context. It could be blog, report, MITRE ATT&CK, etc. Wherever it is, right? You should have supporting information and detail that you'll be using to hunt, right? I think just move just up, right? So this is what you should have. That is one. Another learning that we had is a hunting technique, right? The hunting technique that we really saw is process of elimination. This is a very common technique applied everywhere, but we do apply while writing querying is remove all benign known behaviors, right? How do we do that? We filter via filtering. What is the fundamental why are we doing this? The fundamental principle is the smaller the data set, the easier it is to find the outlier, right? Or bad bad behavior, right? So ideally what we are also doing is we are solving needle in a haystack problem, right? So this was one good and understanding if we are trying to do um, the base hunt in if you're trying to practice a hunt, is you get to learn how you actually pivoted and reached a point and devise back all the learnings and retry them when you're doing your next hunt, right? Okay, this was just one. We'll just see one more, and I'll put this data set in the uh, in my Git repo so that you can go back and download this data set and start hunting. So you don't even have to simulate all of this. Just get the data set, ingest it into Elastic or whatever sim that you are using, and start hunting. For the third one that we executed, right, we did three: persistence, I believe privilege escalation, and command and control, if I'm not wrong, right? But we did three, and we'll do two of them in the video. One will be for you to practice and comment back the query or the hunt that actually worked for you in the YouTube video. If you have questions, also do put them. I'll try to help them and give you the answers, right? I'll DM you the answer. If you want to reach out to me, you can reach out to me over LinkedIn as well. Cool. We'll go to the second technical hypothesis. Our base hypothesis would be, right, uh, base hypothesis would be Again, similar. Let us let us just say that abusing and leveraging. For the sake of notation, I'll also note here what did we actually simulate. We simulated persistence. We simulated defense evasion, and we also simulated command and control. Right. So for this time, what we'll do is we'll not go to MITRE. Right. We have been asked to hunt for. Um, we have been asked to hunt for defense evasion. Right. Our attackers are evading our defensive controls, um, which are deployed on our windows up, which are deployed at our endpoint level. Right. Let's hunt for defense evasion. Or CISA just released a threat report warning everybody that a popular attacker X is using defense evasion techniques to bypass security controls at endpoint level. Right. This could be trigger. Right. This is your assumption. Now the technical hypothesis would be, right, again, structured unstructured approach. We'll take a structured approach, so I'll not build all of this. So we'll say, what tactic do we know? We know tactic is defense evasion. We know the environment as Windows, right? Now this time we will focus on the two popular defense evasion techniques. One of them is fake file fake slash masqueraded. Actually, it wouldn't be masqueraded, it would be fake file slash process execution. What it aims to detect is, I could choose probably better words for this, but I'll explain what it means. It means that what we're targeting is non-standard or system binaries running from non-standard locations. Right. This is one popular technique, right? For example, an attacker would drop a file or drop a process calculator.exe, which is running from, say, your temporary location, which is not its original location, right? Calculator.exe isn't supposed to be in temp, but seeing the process name, you would feel this is a genuine process. But if you deep dive into its path, you will realize it's not a genuine process, right? Sometimes files or processes will have vulnerabilities like DLL side loading, right? So putting them into non-standard directories would mean that they would start loading DLLs from the local location first instead of loading from the standard location, right? So all of that are possibilities why that could be leveraged by this technique. This is one. Another thing that we'll try to detect is obfuscation via extension renaming. right? For example, it could be um, the file should be a.exe, and now it is renamed as a.pdf. So it is accepted everywhere in, say, your web app, or it is a way to bypass the extension checks, right? So we'll try to detect obfuscation by extension naming. So we'll quickly jump back to Elastic and see how to detect fake file process execution. We'll just go back to all logs, or let's do Elastic defend EDL logs. I'll take last one here, where event.category is file, right? And we'll do where event.action equal to creation. We'll first check if a file is created in a non-standard directory and has a name matching or file name matching to a known popular Windows process. So we'll say if a file creation that has happened and the file name actually matches some of the popular Windows processes or binaries, say svc host.exe, um, smss.exe. We'll also do crss.exe. One important one would be lsas.exe, right? We also have conhost.exe. We also have, okay, let's stop, and so on and so forth. And not file.path like c:/windows/system32, and not file.path like sysval 64. Yeah, it is a backward compatibility folder, so this folder might also have the same binaries. um, so this query now gives us if these files with these names are written in anywhere on the system except these two files, right? These two folders, sorry. So we'll quickly execute them. Yeah, I think we are not using the right function here. We'll use r-like, which accepts regex. Yeah, I think so. Yeah, so coming back, this, if you run this, you will get all the file uh, names or processes, file names that are written on the disk in the non-standard directory. So if I say winlogon.exe, right, you can keep on adding to this list of binaries that are system recognized standard and should be in system directory and WoW64. You can also add binaries from other standard directories, right? There are more standard directories available. For example, you could do uh, and not when sxs, right? Or say in prefetch, right? So all of these are some standard directories, and then there would be standard binaries. You can start hunting for them via this. Coming back to the results that we have got, let me do file.name, file.path, we'll do process.name, okay. So we have the process that wrote svc host.exe in this file path, right? So this is something that is suspicious and should be investigated. We'll go to the next query, right? Or the next hunt that we planned was obfuscation via extension renaming, right? So we would try to detect if there's a file written on the disk whose extension doesn't match the um, file header, right? That would be as simple as it is. So this is tricky because it also depends on the kind of tooling that you have rolled out, and not all the EDRs would actually capture the header bytes. But if you don't have that capability, OS query also captures MIME type, so you can correlate via that. Ideally, you should have a system of capturing the header bytes of the file written on the disk, right? So what we'll do is we'll say this is again file create. So what we'll do is this is again a file creation. So we'll say file created, and we'll say and where file.txt dot header bytes is not null, right? We'll put that check so that we are not dealing with null data, and then we'll it shouldn't be where again. And we'll then pipe in and say where we don't want the file extension to match the header bytes, right? So we'll say we'll put two conditions for now. Say file.extension in, we'll put some images, jpg, jpeg, png, gif, right? And header bytes is like for RAR archive, it is it starts with 526172, so we'll just say 526172, and we'll just put star, and we'll also say the same thing if there's a image file masqueraded as 45A, right? A standard Windows executable binary. Right, we'll run this. We have put an AND here. We should put an OR. Okay. If you can see here, we have two results, right? S01.jpg, which has a header byte that starts with 526172. We'll just copy this and we'll validate this, right? Okay, did not match anything. Header bytes of RAR. Let's search for that. It says 52617221 right? That is exactly something that we had, right? So this means that these are basically obfuscated files, or their extensions doesn't match what the content is, right? Ideally what you should be doing is you should not be writing query in such a targeted fashion, because I've targeted it, because I know the behavior. What you could do is you should ideally be doing and file not like, right? Because, and then give the original extent header bytes of these values, right? Say not in, I think in supports regex wildcards here in Elastic, so not in value of JPG, value of PNG, value of GIF, right? So that the query actually checks if the extension is JPG, PNG, GIF, but their actual header values are not there. So any type of extension header mismatch would be caught, right? And that would be a proper hunt, right? So we'll just conclude these two hunts in section for defense evasion. And so we'll just go back to our this and say we have obfuscation via extension renaming. We detected this. We detected fake file process execution. The third thing that you should detect is, I think command and control was something that we executed. We executed command and control, right? So command and control is something that we need to detect or hunt for. Now I'll leave this open and I'll give you the entire data set from my Elastic instance, so that you can go back, reload this data set into your instance and start hunting. Go and hunt for all the techniques for command and control and figure out good hunting queries and detections for it. If you're stuck somewhere, feel free to put a comment on the video. I'll try to help my best. I'll wrap up this video here at this point. I hope this was helpful and we learned a few techniques of how to hunt. And then there are behaviors that we dived into, right? There were some behaviors like extensions not and headers not matching, right? There were behaviors like fake file process dumped. There were behaviors like schedule tasks via persistence via schedule task, persistence via run keys, right? And one of the techniques that we applied was process of elimination, right? We'll keep on doing this video or iteration of hunts again and again and see what all different hunting techniques we can possibly employ, right? We'll close here, go back and have a happy hunting. I'll try to make up the next video or put up the next video as soon as possible. Stay tuned. Thank you so much.